All right, recording up again. So we're going to look this evening at creating simple flow charts, as in a simple program, adding two numbers, dividing, stuff like that, and putting that into the flow chart with the appropriate symbols, making sure it executes. Then after that, we'll look at the branching, the selection statements. So when you have a selection statement, it's usually in a computer program where you have two things and you return a value of yes or no, right? So less than, greater than, equal to, not equal to, all of those will be looked at, and so on. And of course, looping, another name for looping is to repeat, or as you might hear Mr. Venkatesh say sometimes, iteration, right? So iteration, looping, repeating, all of that is the same thing. All right, so let's get into this. So let me share my screen from the get-go so we have a good idea. So share my screen. This is, let me start off with this first. All right, so these are the flowchart symbols that you need to know right off the bat. There are not many that we've been doing in class. Really, we're doing about 4 or 5. Really, we focus on the input-output parallelogram. That's what this is. Input-output parallelogram. That's what this is. So anytime you're assigning data, or you're assigning any kind of value to a variable, that's input, right? Or if you want to display the contents of a variable, that's output. So the same parallelogram shape, that is this one here, this is what is used for input-output statement. So if you're receiving data into a program or into the flow chart, then that's input or output. All right. Once we're going to use the math operators now, addition, subtraction, division, multiplication, it means you're going to do a process. You're going to do a calculation. So therefore, we use a rectangle. Now, this diamond shape or a rhombus is what we use when we're looking at selection statements and loops. Once you say less than, greater than, equal to, not equal to, that is where you use a rhombus. You're making a decision. So we'll get into that a little bit more. And of course, we're not going to use a circle, the connector. We never do that, right? And the good thing with Raptor is that it starts off right away with the shape for us to start and stop. So we don't even have to pay much attention to that, all right? So let me open the Raptor program now. Anybody have any questions so far? You don't even need to raise your hand. Just interrupt me mid-sentence. Let me zoom this up so my eyes are so good as it is right now. Yes, go ahead.
Good evening. I was asking you to reshare that link to download Raptor.
Oh, okay.
For me, right?
Oh,
please,
that link.
because,
no problem, my dear.
Right. If you have it, I'm not sure if you have it, but
I usually have that pretty close to
please.
me. Coding to kids. All right. This thing here, the repository link. Let me copy it here. Control C and put that in the chat. Right. So here's the repository link so you can download Raptor. So you can download it. I'll give you a few minutes to download it and you have it installed. So I'll give you like a minute or two. So here's the link for that. And while we're doing that, there is a link to a Google Doc that we've been using since morning. Sharing it, you have editing privileges. So copy the link is what we've been doing since morning. Mr. Grant was really running through some really good stuff. I learned some stuff from Mr. Grant this morning. All right, I'll put this in the chat. So this is the Google Doc that I'm going to put the questions that we can look at. So you have an idea what exactly we're going to be doing. So using Raptor, simple demonstration, prompt a student to enter 2 scores to display the total. So we're starting that simple. And then we scaffold on that and we build up all the way through to making sure we understand the if statements and the loops and so forth. All right. So, but any questions so far though? Anybody have anything you want to ask or any other requests? Anything you want to add to what we're doing? Because this is all a team effort. If there's anything you want to add, we can figure it out together. Anybody have anything you want to add? All right. Admit some more persons. All right. All right, cool. So here's our first little exercise. So while we're going through this, while I'm going to do something, I want you to think about exactly what Mr. Banton is going to be doing. Or if I ask a question, thinking to yourself, which shape going to come next, and figure out why the shape is going to be used. And if I deviate from your thought process, then you interject so we can explain why. Now, bear this in mind, persons who are here, participants and friends and colleagues. How do we know as computer teachers who cheat on programming with a flowchart or writing actual code? If you have, some of my classes are pretty big, between option 1 and option 2, sometimes up to 40, 50 students. And if I give 50 students a programming assignment or a flowchart, I'm going to have 50 different flowcharts, 50 different programs. They can look similar, but they'll never look exactly alike. Every one of them will have their own unique twist. If it's even the same symbols at the same place, the terms, give me 2 numbers, someone may say. Someone might say, give me number 1. So it will always be a different terminology or different variables. So don't be afraid to put your own flavor. Here's a good example. Even cooking does not take a cookbook approach. Because after you really learn to cook, you dash away that the recipe book there and start add your own little flavor and spice to the thing. When you look at it, it's way different from the cookbook. All right. So let's start off with this simple principle. Prompt a user to enter 2 scores and display the total. First thing. So let me do this right away. I'm going to introduce you to a concept that I use even up till now. It's called IPO charts. Insert, let me do this. All computer teachers will know this. Input, process, output. All right. What this does is that it breaks your program into 3 components, really. And your flowchart will even exemplify that. Bold this and then center it as well. These are our headings. What the IPO chart does is simply to say to you, hey, what do I need to get into the program for it to work? What do I need to put in? What are my ingredients? Right away, I see here so that I need to get 2 numbers. So I need to get scores, 2 scores. So guys, let's say put SCR1, you need to get 2 scores. So score 1 and score 2. Those are my inputs, getting 2 numbers in. And what normally happens at this side of a flow chart is always the parallelogram. You're always using a parallelogram here. Let me see if I can color code this as well. No, I don't want that color code. No, wrong way to do that. Let me do it this way. Yeah, fill color, make it palish. All right. So over here, so is always a parallelogram. Always. Whether you're putting in, or in this case, you're getting out, this too is always a parallelogram. These two, always. Over here now, this part, the process, is where we will use either the math operators or decision variables, less than, greater than, not equal to, plus, minus, divide, multiply. So once we are here, in the middle part, use the division sign, multiplication sign, addition, subtraction. That is what you find at the process part. In the input is where you're putting data into your flow chart, or the output is when you're getting data out. Everybody comfortable with this so far? Don't be afraid to say no.
Okay, so far.
Okay, so far? All right. Guys, I tell you from now, I don't want to talk to you like I talk to my students. About 400 meters from my school, there's a cemetery. And I oftentimes tell them, if I go to the cemetery and ask a question, I get a better response than what they give to me. It's a silence, like a Christmas silent night. Talk to me, man. Every program is broken into 3 areas. The input, what you need to put in, the ingredients. The process, how you need to use this ingredient. to get the desired output. And if notice the output and the input are the same color. Why? Because they'll use the same flowchart symbol. The process, however, is either determined by the rectangle or the rhombus, depending on if you're making a decision or it's a calculation. All right, so let's go into Raptor now. All right, if we're clear on that, let's go into Raptor. So here we have start. We have our over, start and end. All right, so we need to get in two numbers. That's what our IPO chart says. We need to get in two numbers. So let's get to work, get into two numbers. So we use the input symbol here because we're putting in data into the flow chart. So the arrow pointing toward the parallelogram means data going into the parallelogram, going into the symbol. So click on that symbol. I will click here, save it, and let's call this evening, yeah, Sunday evening experiment. Sunday evening experiment. So here's our parallelogram now with the arrow pointing into it. Let's right click, select edit. And what do we want to do now? We're going to request data. Can I say, hey, you, please enter. I can't so good no colleagues, so I'm going to tell you from now. My eyes not so hot right now. Enter a number to add, close quotes. And then now, what is the container? What am I going to put when the person type in this number? So I'll put a message on the screen, enter a number to add. Where am I going to put that number now when the person type on the keyboard? I'm going to put that into SCR, oops, click in the second window, second dialog box down here. I'll put SCR1. I'm hoping that look like SCR1. Good. All right. Next parallelogram. Right click, edit. Enter a second number. Number 2 for your second score. Let's say second score, yeah. Keeping it simple. And then we go down here now and we put score SCR2 and click done. So now here we have our Raptor so far. Requesting two data sets. Hey, I put hey your. Should have been hey you. Hey you, please enter. Let's imagine that's you, right? All right, edit it and change it. All right, hey you. I know IT persons tend not to be too picky about spelling and grammar, but some persons might be picky here, so I'm gonna just change it. Hey you, please enter a number to add. And when put this number in a variable called score1, enter a second number for your second score. And then I say get score2. So the person type in this data, we are going to actually get the actual numbers they entered. How will we know? Let me put an output here. So for example, output, and let me edit this. And I'm going to output SCR1 plus SCR2. So after we get the two numbers in, we want to see what we want to confirm what two numbers the person entered. So we say done, and let's run this now. All right, let's run this little thing. Please enter a number to add. Let's enter 7. Enter a second number, let's say 11. And you see, we get 22. Well, 7 plus 11 is what? 22? 7 plus 11, 22? No? That wrong, man. What did I do a while ago? Let me check back here. Plus, put SC, oh, it added them up. But 7 plus 11 is not 22. We have a problem here.
Mr. Banton.
Yes, sir, Grant, yeah.
No, man, it's Mr. Gidarisi. You actually have score 2 plus score 2.
Oh, Granny. Why am I
Yeah,
that is why. Oh, score 1.
Yeah.
Thank you very much. Until I'm not seeing 2, I need to zoom this bigger. All my words now on the computer, I have, look like I have a shadow behind it. score 1 plus score 2. Thank you very much. Close. All right, cool. Let's run this again for the second time. Let's put 7 again and then 11. All right, it gives us 18. All right, so it actually added the two numbers, 7 and 11, 18. All right, but then that brings something to mind. All right, what if I want to see just the two numbers? Let me add this person in. Frank. Second, Frank, you having internet problems? Anybody have their cameras on, by the way?
Yes.
Yeah. If anybody have a camera on, turn it off so we can save some data, just in case. All right. So put score 1 plus score 2. So this actually added SCR1 and SCR2. All right. So I guess I'll have to separate them to see the score them separately. Maybe that's what I have to do. Let's edit. Raise hand. Graham, go ahead.
I just wanted to know, when you're using Raptor, right? You don't use a processing box. You just use input and output boxes, or what?
You use the flowchart symbols. But what happens is that when you're putting data into the flowchart symbols, you have to be aware of how each symbol is used. If I answer your question correctly.
Well, no, I know the one that's it. This what I'm not seeing is a processing box, because normally when you're doing a flow chart in regular IT, you'll have a processing box which would be a regular square box. So I just wanted to know if
yes, man. Yes, you can. Yes, you do use it. But what we're doing here, so first off, is that I want you to see the fact that when you enter the data from the user, right, the computer will display like this input box here. You enter SCR1, the person type it on the keyboard, and the SCR2, the person enters again from the keyboard a number. That the truth is you have to open the contents of those two variables right to the screen, so you can see, so you can confirm the fact that those are the two numbers were entered.
I get what you're doing now. I get what you're doing, because I was a bit thrown off because I'm not used to Raptor, so I'm just trying to understand that particular.
My dear, based upon all the testimonies I've been hearing, all of us just learning Raptor since what, last week or a week before? All of us just learning Raptor. Yeah.
All right then, cool.
So let's run this now. So let's say 11, and then we enter 7. So 11 and 7. And then it outputs 11. It outputs 11 for score 1. Output score 1 first, 11 here. Are you able to see are you able to see the output screen over this little window here?
Yes.
Yeah, man, we can see.
All right, cool. So this will happen. 7 score 1 and score 2. Sorry, 11 score 1 and 7 score 2. Let me see me take off my glasses in my eyes. No, look, still the same difference. All right. So that's basically what we're confirming. The fact that we enter the numbers 11 and 7 in that order. Let me delete this now. Now let's get to work and do what our colleague was suggesting. Want to do some addition now. Want to add these two numbers. So colleagues, which shape do you think we need to use in a flow chart now? We're going to do some calculations now. Anybody?
I guess this is the time you actually use the process, which is what you have up there as the assignment or call box.
Yes, not call, the assignment. Not the assignment, the symbol. This one, the square. But I heard Mr. Grant was doing something this morning, and I started to pay attention to it for true. I am wondering, honestly, about truth, why is that this is called assignment? Because in programming, this is not an assignment, you know. You do a calculation and assign the answer into a variable. But let's work with that for the time being.
Okay.
Process. And our Mr. Grant was doing this morning. Mr. Grant, you can interject at any time you want, but you can't answer the question. Okay, sir.
Yeah, man.
All right, and you know why that is, yeah? All right. Cool.
All right.
Cool. All right, so interject and add anything or alter anything as you so are inclined, boss. All right. So we get these two scores now, score 1 and score 2, and now want to add them. So right click here and go to edit. And if you notice this time, depending on the shape, the dialog window over this side looks different because the computer expects to do something different with each shape. So we say set. Let us say sum. I like using the word sum. And it says instead of 2, SCR1 plus SCR2. That is SCR. Look like 1.8 to me. SCR, yeah. Look good. All right, cool.
Yeah, man.
We're done now. Yeah, yes, colleagues, you can't see my eyes really getting messed up because online learning. All right, so sum is going to be equal to or be assigned the value of SCR1 plus SCR2. So whatever numbers we entered in SCR1 and SCR2, they're going to now be added together and placed in a variable called sum. And then the final thing we want to do is to output it. All right. So get an output box, edit, and quotation marks, the total for both scores is close quotes, comma, sum. And now we're done. Oh, granny, sorry. My mistake. My mistake is that, and I should, is plus, yeah, plus sum. Guys, I'm
you
so
use
used
comma
to,
in a different language.
yes, me using a coding.
Oh, me figure.
So reflexively, me tend to just put the comma. Use it in a
Yeah, me
Pascal,
figure.
you use it in a basic language, use it in a C. So my brain instinctively, I just go to that language. Sometimes I'm writing to teach my students Pascal and C, just C language, just chip in my brain. All right, so let's get done with that. Done? All right, so within this message, the total for both scores is, I say plus sum. In other words, output the value of sum. I will run this now, and then we put, let's say 5 and 9. I should get the SCR1. Boy, I'm at the star. When you're going blind, it's not funny, no. SCR1. Done. Cool. Now run this. Let's say 9 and 10. So you get 19 now. The total for both scores is 19. So it's a simple flowchart thing that I'm hoping that everybody not just understands how this is done, but you can do it. If you're confident you have done something as simple as this before, great, awesome. Everybody in here do something simple like this before? Let me check. I don't want to, you guys are coming to my day student, let me know. But I'm very much inclined because people not responding.
You know, to be honest, today the first time I really get a chance to use the
Raptor
software because it wasn't working for me the first time.
Okay.
And this morning I was in the session this morning with
Mr. Grant,
Mr. Yeah, man.
Yeah.
So it wasn't really working, Mr. Bantana. It wasn't really working for me this morning, the output statement, but now I realize because just like you, I was using the comma.
Yeah.
Because I'm used to using the comma.
Right, yeah, man.
But
it happened reflexively.
Yeah, man,
it's like you go back and check your brain again and yeah.
Yeah. So
right.
yeah, man, I kind of getting it now. Getting the hang of it.
No problem. Miss Bradshaw. That's what I get one classwork for the door. And I'm big and serious. I get one classwork for the still. Yes, Miss Bradshaw.
Yeah, what you're saying?
Yeah.
Oh, my hand is still up. No, sorry about that.
Yeah. Okay. All right. So guess what I'm gonna do for you guys? Give me your classwork, yeah? What I want you to do, everybody, and let me pause this right now. Pause. I want everybody to, even if I know what to do, then it'll be like 1, 2, 3 for you. But everybody to do this classwork thing here. Get a number, or get any number and double the number. That's it. That's all I want you to get any number and double the number. Do it in Raptor right now, and We're going to spend the time and check everybody work. Seriously. We're not taking anything for granted that, oh yes, we're good and we understand. Well, no. We want to check everybody's work. So if you're, but then again, question, how many of us here using a tablet or a phone?
I'm using my phone.
Oh, that's gonna be a problem. That's gonna be a problem because there's
I
no
understand the question still, you know.
yeah. All right,
Understand that. I understand.
So you can describe to us what you do then, right?
In a way, yes. Yes, I can. Yeah.
Okay. All right, cool.
Right. So should I do that now?
Well, don't describe to us what you do yet. I kind of want to see
All
that
right.
person who have a laptop, if they can do it and show. So I'm going to give you guys about a question. 5-10 minutes is good enough.
Yeah, that sounds good.
I'll make 10 minutes right off the bat. So everybody who have a laptop or a desktop computer, just do it in Raptor and we share. And everybody get the chance to share and explain what they did and why they did it that way if needs be. Okay, and go through it. So 10 minutes. So run about 4:40. We're going to link back and so on. So this is the one that we're doing right now. Question number 1. Get any number and double the number. And let's say display. Let's say display the number doubled.
Question, on the
Yes.
Raptor thing, when the little box come up, where do you type?
Where do you type? Right
Yeah.
click in the box and click edit.
Right click in the box and click.
Right, point to the box, right click and select edit.
Because I am clicking on the input symbol here. and
Okay, you
it's
want
not-
share? Let me stop sharing my screen. Let me allow you to share. I'll stop sharing my screen so we can see what you're doing. Can go ahead and share, Miss Graham. Da, 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 da.
You're still sharing.
I'm still sharing.
Yeah.
You can go ahead and share, man. I'll you know what make you host so you can do everything.
You can make me just co-host. You don't have to make me host. Just put on multiple sharing.
Host.
Right at the share screen, the little down arrow.
Yeah.
Just give them
Come on.
put on multiple sharing. Oh,
Yeah, that
I never
depends.
put it on for you, since you put me as host.
Mine don't really have some of them features there now. Just pay for the simple one.
All
And
right.
normally, yeah.
So you see my screen?
Stop share. Go, yes. See your screen now, yeah.
Okay. So I'm pressing on the input box, right?
Yeah,
And it's red.
Yeah, and then click point between the arrow between start and end. That's right, correct. Click yes or no. Yeah.
Okay.
Yeah, save your work, yeah.
Oh.
Save it as anything you want.
I don't know.
Yeah.
Oh.
Right. Come now, then right click in the box. Edit. Right.
And then I put this and then say get num. Is get
No. Don't put get num. Don't put get num.
What
You're making a mistake there now, but we're going to wait until you figure it out. In the window below, that long window,
yeah,
put the variable you want to use. A or B or C or num or num1, fine.
And
yeah, done. No, put it in quotation marks. Put the
I
whole
was
phrase
just
in
about
quotation
to
marks.
ask you that. If we
Yeah.
don't, we have to use the
Yeah.
quotation mark all the time.
That is the error that she was making. I said, well,
Okay.
I don't want to throw off anybody. Yeah. Go ahead.
Okay.
No,
So, wait,
no, just tap anywhere. Click anywhere. Anywhere outside the box.
oh, oh,
Oh, you need to click down. Yeah. All right. Please
oh, so
enter
I
a
am not the
number.
one who put get. Oh,
No, it put it itself.
okay,
Right.
okay,
Yeah, man.
interesting.
Yeah.
So, what
So
is
if
it?
you realize
what's
the input
question
box is still
again?
active. Is the input box is still active? So if you click
Yeah.
again, that's the one that shit going to show up. The number said get a number and then double the number. Display double the number.
Okay, okay.
Right. So you can stop sharing. Stop sharing.
Okay, okay. And I put on multiple sharing so anybody can share now.
Okay, everybody can. Okay, good.
Yeah.
When I used to Zoom, you know, a Google Classroom I used for decades, for like
Oh,
5
it's
or
Zoom
4
I
years.
started out before I move on to Google.
I never liked it because it used up too much bandwidth. Use up all of your bandwidth. Use more bandwidth and resources than thing there. Anybody else finish and want to share anything?
Yeah, man, I'll go ahead.
Who's that now? Mr. Graham? Or Mr.
Mr.
Lilly?
Lilly.
All right, Mr. Lilly.
Yes, sir.
You get to share now. All right, boss. Run now. No, nobody copies. No copying. Oh, this is patented work.
All right, so what are you? Yes, we should just get
I'm
a number for the
not seeing your screen.
Oh, you're not seeing the screen?
No, I'm not seeing your screen. If
It'll
Miss
come
Graham
up
is
here.
sharing, could you stop sharing, please? If you're still sharing. Murray, Denzel Murray. Who's that? You have a question? I see Mr. Lilly sharing, but we're not seeing anything at all. I don't know where you are.
Oh. Hold on, let me just.
But Denzel, you have a question? I said Denzel and Hall have a question. Murray and Hall. Well, let's start another Mr. Lilly.
Yes, I'm Hall while he's
Yeah.
getting ready to share. Good afternoon, everybody.
Good afternoon, Mr.
Good afternoon.
I want to find out something. It might sound very foolish, but I just don't know.
No, man. No, man. Yeah.
With the coding thing, when the instruction comes, like I'm supposed to get the number, is it that I can have that number in mind or a specific number that comes with the actual activity?
No.
Is it open to my personal?
It's open to your personal. Yes,
number?
you can put the number in if you want. Like I said, num equal and particular number, or you can have the user enter it from the keyboard. Any way you want to do it. It's just your interpretation right now. You follow?
Okay, so that means when I'm going to be putting in the first assignment box there, a number.
Yes.
Like when Mr. Vengatesh gave us the activities.
Yes.
When I put that in, it's my personal number I have in mind, or is it that I'm supposed to be calculating something to get the number he has in mind?
Oh, okay.
I'm lost there.
Oh, you're lost there. All right. So looking at the question that, for example, not Mr. Vengatesh's example, because he did quite a few scenarios, but like in this case, now I say, get a number. You think of any random number. So I decided to put any number. So I put the phrase it and say any.
Oh, so
right, go ahead. Yeah,
right.
Go ahead.
So when we're all doing the activity, you could be thinking of number 9. I'm thinking of 7. Somebody else is thinking of 14. That's what you're saying?
Basically, yes.
Oh, okay.
Doesn't
If
matter
I could
which
try,
number.
Mr. Banton.
Yes. Because I was
Oh,
If I could
say
try
something
to add
else.
Mr. Banton.
Yeah, man, go ahead, go ahead, Sir Grant. Go ahead, man. I was going to say something else,
So,
but let me make you go first.
so Miss Hall.
Stefan, me not hear you. Go ahead,
Can
go
yes,
again.
sir.
Yeah.
You hearing me?
Me hear you now. Me hear you when
Hearing
you,
me? Oh,
me hear when you ask the question, yeah.
Yes, Mr.
Me
Grant.
hearing you, yeah.
oh. So if you remember, Mr. Vankatesh and Mr. Banton during the classes were repeatedly reminding us that depending on the problem, two things they kept reminding us. Your solution or what you put in the flow chart depends on the problem you're given one, how you interpret the problem two, and how you plan to solve the problem. So some problems, like the one Mr. Banton gave us, doesn't require you to set a value for a number. What it wants is for whoever is going to use the program to put in some number.
Yeah.
So in that case, it's not necessary to assign any value. But the activity you might have been thinking about, which would have been different, required you to start with a number in order to solve the problem. So that would have been a different situation now, where you would have to say, all right, it needs to start with this number.
Okay, so that's what I have not been clear on, because this is very new to me. So I was wondering, is it that I am free to decide on what that number is doing the flowchart and then work towards
the expected outcome.
Right.
Yes.
That's what depends on the problem.
Yeah.
Okay. All right. Thanks much.
But I don't think Mr. Banton ready for those type yet.
No, we're not ready for those. We're not going there yet.
Lovely. All right. Thank you. Yes.
Come on. Mr. Murray. Benzo?
Yes, sir. Good afternoon. Yeah, good afternoon. You hear me now? Yes.
Yeah, I hear you now, boss. Yes.
Yes, I want to share my screen in terms of what I do.
Okay. No problem, man. But I think Mr. Lily was going to share something with us first.
Right. And just to mention something to clear up what Miss question.
Yeah.
Is that whenever we are doing algorithm or stock code and those things, right? We normally look at the variables first, and then we use the numbers or whatever to test it. The algorithm. Right. So the numbers there, it can be any number. Like you said, get any two number. They don't give a specific number. Right. So everybody, as you said earlier on, that if you have 100 people doing the same problem, you can have 100 different solutions. Right. Because everybody will come up with different numbers.
Right.
Right. To solve a problem. Right. So that is what makes the flowchart or the algorithm very unique.
Yes. Very true, Sir Murray. Very true. Mr. Lily, start out your sharing yet? Okay, if you're ready to share.
Yeah, man, but I don't know why you're not seeing it.
We don't know either.
I guess
Anybody else see what Mr. Lily sharing? Anybody else seeing it?
No, it's saying has started screen sharing, but nothing.
Mr. Lily, I'm gonna make you a host there, boss.
All right, so I'm gonna stop sharing and just allow somebody else to go ahead then.
Mr. Lily, before you give up on that though, I don't know.
Yes.
Is it because I'm pay for the cheapest version of Zoom? I don't know if it pose
No, man, I think it probably has to do with my Wi-Fi because it's been acting up from morning.
Oh yeah, definitely. If your Wi-Fi act up, you can have problem sharing for you. The extra bandwidth, yes.
So,
all right, no problem. Sir Murray, you're on the floor now, sir.
Yes, sir. Thank you. Right, so I have my input where I got my get a number and double the number.
Somehow just white screen there, I see. let me. I'm seeing there's a white
White screen.
board thing. Yeah, there's a white screen.
Yeah,
Yeah.
man. Same thing I see. This look like it's a whiteboard they share, man. A whiteboard they share.
Yeah. Yeah.
Hold on. I'm gonna stop share.
You do it in Raptor or is
Yeah,
a
it's a
whiteboard?
whiteboard they share.
Rapture.
Raptor? Okay.
All right, I'm coming.
Come on, go again. Ah, yeah, we're good now. We're live.
Yes. Right. So we this is the input.
Right.
Right. Where that is that. Here.
Mhm.
Right. This is the process.
Uh-huh.
And this is
Now
the
come Mr.
output.
Grant deal with that.
And
Mr. Grant,
this
you're
is
gonna do that
output.
process there, here, sir?
Right.
Maybe
This is
you
the
can
output.
clarify that better than me. Yes, sir, Maria, yeah.
Yeah, that's the output.
Yeah.
Right. And this is the outcomes in terms of
Enter 3. When it comes up, enter 3.
3.
Yeah.
The enter 3.
That's why you use.
Right. Give it 9.
Yeah, you read my mind. Because that's the exact question I was going to give you first. Find the square of a number. That's what I was thinking first to put there now. But then chairman, I said, let's double the number rather than square.
Yes, that is what I thought you were going to say. What did I say?
Yeah. So
Right.
is the wrong operator that. But your flowchart works marvelously fine. Works fine. Just give the wrong output, which means that would be more in programming that called a logic error. It works, but to give you the wrong result. Mr. Grant.
Right. So it's the assignment that would need to change.
Yeah.
That's what you have in
No,
the
one
assignment.
in the middle. The one in the middle. Strip in the middle. Yeah, that one, yeah.
Right. So the normal rectangle is the assignment. So what you have there is what happens when you square a number.
Oh.
But when you double a number, what you're actually multiplying by?
You multiply by 2.
When you're doubling a number, I prefer you tell me, man, when you're doubling a number.
By 2.
Yeah.
By 2, right.
Right. So this is
but what you actually
right.
wrote is
a square, yeah.
But
a next problem, if you don't mind me jumping in here, is
no
where
problem,
he has num1 being assigned back to num1 there, he needs another variable for another variable name. So something either like total sum.
Right.
So that is a problem as well.
Right here?
Yeah. No, even at the second one too, because I said num1 basically is going to receive num1 times 2. You could have put anything like dub equal num1 times 2. It would work still, it would work that way, but you would have a problem with your variables if it were a larger program.
Yeah, and also that would be a logic error. So change that name to sum or something like that, or double.
Or double.
I think what was happening here is that the
sorry, but I dropped out.
Value would be replaced from num1.
Right. So right, good.
Before you move on, Mr. Banta, I still have to go into the class. I was saying that you don't necessarily have to change the name. Well, I assume that the reason why they suggest you change the name is if one, you need to reuse that value sometime later.
Right.
Or two, for some reason, you don't want to alter what was originally entered.
Yeah.
So it's not necessarily that you have to. I don't remember who said it. It's not necessarily that you have to.
It was Carla who said it.
Yeah.
Because in terms of logic of the program and everything,
right,
you would end up with a logic error on some for depending on the type of program you're writing. So it's good practice from this stage, not to do that unless you definitely want to change.
Right. Yeah. Because
that's what I'm saying. But
so based on the question, that's how you do it. If it was another type of question now, then you could keep the num one, because then you'd want num one to change, either increase or something like that.
Maybe I didn't explain what I was saying, but let me try and say it a different way. So if in this case, right, with this problem, he did not rename it, what would have been the logic error?
All right, what we're saying is that the program would work and give the correct answer. So it would not be so much of a logic error in this program. But if you get but if you get in this state now where you do this, eventually you're going to find yourself in problems with that eventually, because what you're doing is that using just one variable when at times you need 2 or 3 different variables. And then we're going to create confusion. Yeah. So because
I get that, you know. But that is exactly why though I wouldn't agree that it is necessarily correct to say that you must give it a different name either. Because if you take, for instance, other problems that you're solving where you need to change the number, then a person who is just learning it might feel like, oh, because I altered this, I need to give it another name and I need to keep giving it different names, when the truth is you don't really need to, because you want the program to be changing the number by itself over and over. For example, when Sir gave us, and we were using the count.
Hold on, Mr. Grant, hold pause a bit. You see, because we're going stage by stage, we don't want persons who are not so comfortable with going so far yet get overwhelmed and feel like they're drowning out in the deep blue sea, you know.
No, I know that.
All right.
No, cool. I know that. That's why I'm saying that it wouldn't be best to say to him that he must give it a new name, because when he gets to problems like those now, where he doesn't need to give it a new name or he's not supposed to give it a new name, he'd be wondering, then why didn't I rename this? When earlier he was told that every time he does an assignment, he needs to change it. So what I think,
I get what you're saying,
right. So what might be better to do is to explain why you would recommend he should change the name now, rather than say, give it a new name.
That's exactly what we're doing. Because the problem is this, that we don't want to. What Miss Carla was saying is that when you're teaching coding, you need to develop some good programming habits. All right. And in this situation, even though it worked out that using num1 worked, if you're given another problem, even as simple as this, you will end up in logic problems. I think that's what Ms. Carla was saying. Because the truth is, in this situation, it's good programming practice not to keep using the same variable over and over. Unless when you understand it now, how it works, then you'll know when you can use the same variable all the time. But right now, just learning is not a good practice. I think that's what Miss Graham was saying.
It's okay to say, Carla, I don't have a problem. But what I'm saying, you're correct. What I'm thinking of is the fact that we have to go to students, right? And it's best to take them through the stages as basic as possible. So you start with the simple to the complex, so that they can see it, that depending on the problem that you're doing and everything, then you need to let it flow in a certain direction. And based on a question, you needed to find a double. So when you look at this problem, even if it doesn't have any thing written up about it, you look at it instantly and say, oh, they're doubling the number, compared to if you had back the norm, then there might be some confusion for the child going forward.
And not only that, too, but later on, hold a second, when you're doing trace tables, if we get into anything like that, this program would have really make you get gray hairs if you keep the same variable all the time. It'll really mess you up if you go to the trace tables later on.
I don't want the entire session to be about it, but let me give you an example why though I was so hesitant to do it. I get why people do it, you know, because it's the same thing with math. So take for example at the primary school level, when students are given problems like 3 minus 5, the simplest way for the teacher to get the student to learn what they want to teach them, they tell them 3 minus 5 can't. But that is not true. 3 minus 5 is -2.
Right.
By the time they come to me now at the high school level, and I need to teach them directed numbers.
Yeah. Okay.
Every time they see something like 3 minus 5 until all the way up to 5th form, them still say it. 3 minus 5, sir, can't. Because it was drilled in their mind at the primary school level that it can't be done. But you could understand why the teacher said can't.
Yeah.
Because the teacher didn't want to get into the explanation of directed numbers. It's a similar problem.
It's not on the curriculum.
Exactly. It's a similar issue now come now when they actually start learn, them come at the high school level, and it's something we as teachers do over time. We give them the simplest explanation, and then when they get to a more complicated thing now, they get confused. So even at the high school level now, by the time they reach 1st, 2nd form, the teacher said to them, say, subtract the numbers, keep the sign of the bigger number. So when you give a student something now, like -3 plus 3, sorry, -3, no, I want to say -5 plus 3. The student go and say, all right, subtract them, we get 2. Keep the sign of the bigger number. They might say +2. Why? Because we told them 2 contradictory things. We told them that positive numbers are always bigger than negative numbers. So even though them see -5 and then see +3, them say, but the positive number must be bigger, so the answer must be positive. But the correct thing we were supposed to tell them is subtract the numbers and keep the sign of the one with the larger absolute value. So that is why I was a little bit hesitant to agree with saying to Sir, no man, rename it at first. But now that it has been explained why you're recommending renaming it, I think that's better. And I think that's what we should do with the students too.
Yeah. But me get you, Mr. Grant. Me get your passion
So
with
Mr.
that one there.
Banton,
Because they really give you some problems.
Trust me, man. All 5th form, they still do it.
Yeah, but as you rightly said, Mr. Graham was saying, and we all concur on this, is that you teach them the basics, and as they mature in it, you teach them the how and the why, because that's my philosophy as well. If you just know what the answer is, but you don't know why it is the answer and how to get it, might as well you didn't know. So that is the premise, and I get Mr. Grant, you get some headache over that. Sir Lily, you have your hand up for a while. Yeah.
What I was saying is because what I thought you had said was to print the number. So what I did was, and that's where I don't remember sir's name, would probably have some issue,
Mr.
is
Grant, yeah.
if you had asked the user to print back the same value as well as the new value, which is the double value.
Then you're in a problem if you never name it, right?
Right, exactly. That's even a better explanation. That nickel nail on the head. Even more now, dead center. Bullseye. All right, I don't want to continue this much longer because I don't want to overwhelm anybody. And so, but I hope everybody's able to follow and learn from the better or best practices that we're using. Because there's when you're writing code, which is what we are doing now, you might find yourself with more than one ways to do something, but sometimes one way just makes sense that you do it this way because the other ways, even though they're correct, wouldn't work out for you. You know, so even the steps of problem solving, define the problem, evaluate or assess the problem, then, you know, determine solutions, then select the best solution, implement it. So even in the very sequence of how you go about problem solving in programming would require some approach like that. Because when you let me see, because we have some more to share, not true? All right, here's another one now. Who this, Mr. Lily, are you this?
Hold up, Mr. Bantam, I'm gonna run now. You're at time for my class.
No problem, sir.
All right, bye, everybody.
Bye-bye, Mr. Grant. Take care.
Yes, sir.
Who's sharing now? Mr. Lily, you sharing? You want to share, Sir Lily? You can't share yet, or you're still having problems? All right, good, yeah.
Hold on, Mr. Banton.
Yes.
Just to backtrack a little bit because I missed out on that part, right? Because I'm moving and listening at the same time. You guys were saying something about the use of one variable over and over.
Yes, that there'll be some challenges with that depending on the program. Yes, there might be some challenges with that.
Okay.
Yeah.
Okay.
All right. So, Mr. Lily, you want to explain to us exactly what you're doing here, sir? Oh, Miss Lindo.
Yes, because
Sorry.
yes.
Mr. Lily, now responsible for look and see who really I share. I thought it was you. Sorry. My apologies,
Okay.
my dear.
That's understandable. I am very, very new to all of this.
Yes.
But I was following what you did. So if I should run it,
yeah.
But that's the only thing I get. And say I put in 7, you say I double the number, right? So
yeah,
that is 7. And then it put in another 7. Then 49.
You get 49, yeah.
Okay, so that's it.
That's
all I have to do, sir,
that's
is
it.
To learn that I need to put the quotation and
yeah, that's it for what you're doing.
But I know the signs. I got the signs already.
Okay,
different
cool.
sign like the multiplication and that sort of thing.
Right, good.
So that's it for me.
That is it for you. Yes, your flowchart works fine, but you kind of miss the question and the solution a little bit still.
All right, tell me about that. What should I have?
All right, it says get a number, get one number or any number, get any number. So any is just one number, get one number. So you could work with SCR1 alone and delete SCR2. Click at the box with SCR2.
So SCR2 should not be there.
SCR2 should not be there because they get any number. So it really means get one number, yeah.
So I would have this box, but I wouldn't have this one.
Yeah.
So I can delete
to
this
answer
one?
the question that we are doing, yes, that we're currently doing, that's it. You have to delete that box, yes. And they say multiply now. So you have SCR1. There are 2 ways you can double a number. You tell me how you double.
Let me edit it.
Right.
All right. So you're saying there, what should I put in the set section?
No,
then?
man, set is fine, but in the 2, what do you want to do? There are 2 ways you can double a number.
Oh, use the number 2.
Yes, you can use the number 2. That's one way.
Yeah, and
so to be
add them. Add the number
you
twice.
could do it. Thank you very much. You could do it that way as well. So put that in the 2 area, that bigger window. Put it, type it, you know.
So in this section, I would say, could I say double or should I say just sum?
Just put the calculation as it is. So the variable that you used to get the number was what? The variable you used to get the number was what? What's the variable again? Move that little window to the side. Yeah. Now go up a little bit further. Go up a little bit further. Is it like a dinosaur?
The little dinosaur.
Yes, in there. Look at a kangaroo.
A Little
that same window,
here?
right? Yeah. Point on him. Yeah. Point. No. Point. Point. Hold the mouse button and then move him to the right or to the left, whichever one.
Oh.
Go a little bit further to have the word statement. Go a little bit right. Hold it and drag it. Look a bit to the left or to the right.
Okay.
All right.
Right.
Cool. So which variable did you use to get the number from the very first shape, the parallelogram that you put in? Which variable got the number? The shape
Okay,
above that.
what I did was to multiply.
Yes, it multiplied.
Yeah.
Right. But now what you're doing, you multiply SCR1 by SCR2. SCR2 is no longer there.
Right.
So look at the shape right above that, the input parallelogram, and which variable you use. Which variable contains the number now?
Score, is it 1?
Yes, score 1. So that variable now contains that singular number that you want to double. So you have to get rid of score 2, and what would you do with it?
Okay, so score 2 is out.
Right.
Right. And then we'll say by 2.
By 2, that's one way we can do it, yeah? By 2.
All right, by 2.
Right, and then you're done.
Oh, okay.
Done.
All right,
All right,
and so
now
if I
try
run
your
it
flow,
again,
yeah.
and I put in, say, 5. Okay. Oh, and there it goes, it give me 10. Okay, good.
Bullseye, that's the correct thing.
Thank you.
You're most welcome, my dear.
All right.
All right, anybody else? I don't want to pick on the name, you know. We see a very wise person here, Solomon. Solomon, how you feeling?
Good afternoon, sir. Good afternoon, colleagues. I'm perfectly fine, sir. I am using, yes, sir, except for the fact that where I'm at, I don't have a laptop at this moment to use. So I'm basically working it using pen and paper, and I understand clearly what's going on, sir. I understand the symbols, how they are used, and so forth. My challenge is the loop.
The loop.
I think that's,
we're going to get to the loop eventually,
yes,
because we're going to keep going until we get there. So if it takes like next 2-3 hours, I'm game for that. Just want to say, when we get it, everybody understands at that point in time.
Yes, sir. Because if I should walk you through what I wrote down, because as I said, I'm using a cell phone, so I would not be able to use the Raptor. So I have my elliptical shape at the top to start. Then I used the parallelogram, and I said, all right, enter a number. From there, now I have my rectangle. So I'm using pen and paper, as I said. So I have my rectangle. In my rectangle, I put double. Then I have this would be my assignment. As we know, the rectangle is used for the assignment statement. So I have num1 times 2. So whatever the number is, you're multiplying it by 2. And as you said, there's more than one way in which you could have done that. You could say num1 plus num1.
Right.
And then you could have still given you the same result. Then for the output, you have your parallelogram again, and I put the number doubled is, and you know that whatever the number that you had that you have doubled, then the answer would have been displayed if I was using the Raptor. So I am here sketching it out, and I understand it clearly, just that I am not able to run it and share it with the rest of the class.
All right, cool, no problem. I have 2 concerns though, because you sound comfortable and confident with it. So from the time you said please enter a number, what would have been good if you put num or num1 in that same box, so you keep it fresh in your mind that the variable you use to get the number would be num1. At the end, you'd ask, you say you have that. Okay, you have all of that. Okay, all right.
Yes, sir, I have all of that. But it's because remember with the Raptor now, based on the input, then it would have allowed you to enter the variable name.
All right.
But
I just want to make sure.
Yes, sir.
Let me see your answer.
Yes, sir. I understand thus far. My challenge is the loop, and not just the loop. I think where I sometimes have a challenge is how the question is coined. Sometimes, yes,
I realize
dependent on, Dependent on how it is coined, it might throw you off. You might get a portion of it correct, and then a next section you might misinterpret it, especially some of the questions that Sir did the other day. I was a bit lost with some of them.
Right. Sir looked like
Yes.
him learned English a few years ago. So he's not so comfortable now with because even the other day, remember I had to ask him if this is exactly what you want to say and structure the question.
Yes, sir.
But,
Remember,
yeah,
you went
right.
ahead and you did some restructuring.
Right.
So
So I think
yes.
it is second language, and the truth of the matter is that, you know, we know that we have, this is one of the reasons we're doing this as well. So that we'll make sure that Sir knows programming. You can't see that he knows in bad for the programming. But
Yes,
the thing
sir.
that's beating him is one, or beating us with him is one, in accent, deep, you know, and two, that he even how he enunciates and how he explains himself. You can't say putting the words together. Second language, maybe not so easy. But you know, we cannot making sense
Yes.
of it, and we work together and make
Yes.
sure we all get the best out of it at the end.
Yes, sir. That is so true. That is so true, Mr. Banton. Thank you, sir.
No problem. ABC. ABC. Guys, come on. I don't want to call on everybody, you know. And I don't want to move forward and know that and lose anybody, and to realize that when the questions come, it's because we did not all understand this part that we're doing now clearly enough. All right, cool.
I'm sharing one done.
All right, cool. All right, thank you very much, Sir Andre. All right, cool. Very good, very good. Run that down, Mr. Andre. Even though we see it actually, the output and the console that it actually worked.
Hold on.
Yeah.
Okay, correct.
So the play button, just tap the play button now, you're good.
I'm having some issues in terms of freezing.
Oh, okay. What number you entered?
Just entered 25.
Okay, cool.
And
awesome, good, very good. All right, Mr. Gidar Singh, you're good?
Yeah, I'm good. I'm actually close to home, so I can join on my laptop when I get here.
Okay. Oh, you drive. Hold on. I'm not driving, Mr. Gidar Singh.
Yeah, I'm being
boss man. We don't join that choice.
No man, I'm in the back.
Yeah?
I'm in the back. I'm in the back.
okay.
I'm in the back.
All right, boss. Because we kick out that meeting, you know. Trust me, man.
No, I wouldn't do something like that.
All
no,
right,
I
boss.
wouldn't
No
do
problem.
something like that. Come on.
Good to know, boss. Hope get home safe and everything, and you link up. Cause we'll be here for another couple hours, it seems.
No problem.
Frank Paulette. Paulette.
Sir, I'm trying to my problem is that I understand how to structure it, but is to put it in the table. But my internet is really unstable, and so I'm in and out of the class. So the minute I learn something, then I'm out, and then I'm in again. So I learn as you go along, sir.
Okay.
And then I'll put it together. Thank you.
Today is one of those days where Miss frankly is asking me to accept this by faith. All right. No problem. So we're all good so far, colleagues? We can work in some branching now, some selection statements.
Yes, sir.
Yes, sir. Yes, sir.
All right, cool. So let us go again. All right, so here is what we had, right? So we have score 1. So this is our little flow chart. We add some numbers. Add, multiply, subtract, divide, doesn't matter. Same thing. All right. So now here's what happened. we now want to do a simple calculation. We want to say, okay, if we average the numbers, the scores of these students, if they get above a certain score, what happen now? Let us say you pass the subject, or not, let's say pass. You move on to the next grade. And if you don't pass, you're going to repeat the grade. All right, so let us do that calculation. We say, we can modify this one right away. This, and because me going blind and I need my thing at 200%, I don't want to add too much shapes. So let me modify this one, edit, and change the average. So say AVG gonna be equal to, come down here, open brackets, that come out over here, and then divide by 2, and then click close. So average is going to be equal to both scores added together divided by 2. What we're going to do now, there's a way we can do it all together in one statement, but we're not going to do that. We're going to keep it as simple as possible. When I don't know how many persons here teach your children programming or so forth, as basic as you see, I'm giving you now, that's what I do with my students. I don't give them nothing complicated. I don't want you to think about how to solve a problem while thinking about the other way of how you can put it into the program or in the flowchart. We're using simple problems that everybody knows to solve. All you think about is just a flowchart, because you know to solve the problem already. All right, so we have average equals basically score 1 plus score 2 divided by 2. So now we need to make a decision. Decision meaning basically we need to evaluate the average to see if it is more than a certain number. Let us say I think for me a reasonable pass mark is 60. So if you get 60 or more, you move on to the next grade. And if it's 60 or more, it means that it must be less than 60. So therefore, then you're going to repeat the grade. So now we go to the decision, the rhombus here, and then we click this shape. Put it right here. So between these two, between this and this, click here, and now this comes in. We can just delete this though. Let's delete that. I'm going to delete that right away. All right, so the computer, Raptor, automatically says yes on the left, no on the right. Truthfully, when I was learning programming at college, we were always told, insisted that yes should be on the right and no on the left. So sometimes it could also flow downward. So the yes could be down here or on the right, and the no would always be on the left. But that's not how it works with this program. So yes would have to go over this side. So if you, what we're going to test now, if the average is what? Somebody tell me now. If AVG is what? AVG is what? Greater than or equal to, because it is 60 or more, right? We go to 60, done. That's our test. Like the regular if function that we write in a spreadsheet, we say we carry the test. If this number is greater than, if this cell address is greater than a particular number, carry out this calculation. Same thing here. The rhombus here is saying to us, carry out a calculation. You need to make a decision. You need to compare what is inside the word, the variable average, compare that with the number 60. If it's more than, equal to or more than, then what do? We're going to output this. Output, right click. Yes.
Anton.
Yes.
Just a minute. You were saying something just now. I'm in and out of the session, but where you say about let me see, go up again. Oh, I'm seeing it now. Where you say that yes is on the left and no is on the right. Right, because I'm used to the other way around.
Yes, me too. Yeah.
Right. So would there be a confusion? Because
no. Because the word yes, so the word yes is here and the word no is there. So if you do the flowchart.
So what if it is that we would structure it using no yes on the right and no on the left? Would there be a problem with Raptor?
No, man, no. That's what Raptor does by default, you know. Yes is on the left and
Oh,
no on
this
the
is
right.
default. Oh,
But yes,
I
it's
have
default.
not got mine downloaded yet.
Yeah.
So that's
But
it. So I have not interact with Raptor yet.
I am going to see if there's a way I can have it flipped around because it still look weird to me now.
Yes.
If I can get the yes on the right side and the no on the left. So far, I've
Okay.
tried it a few times and I couldn't get it. But now we're finishing off
Oh.
reports. So as soon as
Oh.
I've done commenting on the grade 11 reports, I
Yes.
am going to then go and mess with this big time this week. When I spend most
Yes.
of my time on Raptor this week because I'm excited about it. I want to start to see
Right,
my
it
thesis
seems
from grade
because
7.
now it's the first time I'm actually really seeing it because I'm always in and out and so on. But I think I'm loving this, so I'm going to see if I can play around with it too.
Yeah, man. Play around with
Thank
it,
you
play
for
with it,
that
mess it up, anything. Yeah,
clarification.
man. So let's see if we can. So later on this week, if I figure it out, I'll share it with you how to get yes on the
Okay.
right hand side or no on the left. 'Cause that's how I prefer it. But right now,
Okay.
I stick with what it said. Can't change it right
Okay.
now. Right?
All right. Thank
So,
you.
right, good. So listen how it look weird. So if average is greater than or equal to 60, yes, what happened? Move on to the next grade. Move up. Move on to the next grade. Close bracket, close quotes. Done. And then now, if next one, if it's not greater than or equal to 60, means that it must be less than. Edit. Unfortunately, you will repeat the grade. Better luck. No, work harder next time. Work harder next year. All right, done. So this is our flow chart thingy. Let me scale it because we can't see everything. Down to 150 or even 175. Yeah. All right. This is our flow chart. We start off, get score 1, get score 2. We average the scores by adding score 1 and score 2, dividing them by 2. And then now we will go and say, if the person gets, we do a rhombus now, if we make a decision, compare what is inside average to 60. So once the data or the number that's inside average is greater than or equal to 60, we'll display on the screen, move on to the next grade. If it is not greater than or equal to 60, we'll have, unfortunately, you repeat the grade, work harder next year. So let's run this now and see what happens. Run. All right. Please enter a number to add. Let's say 90, but it's obvious. And there was a 100. So this person going obviously get more than 60. All right, move on to the next grade. Done. Close. All right, clear that. So let's run it again now. And this time some lower numbers. Run this again. Let's put this person got 55. Don't bring them too low. And then they got 59. All right. Unfortunately, you will repeat the grade. Work harder next year. Done. So this is what the computer does now. It evaluated the statement and realized that the number inside of average is not bigger than 60 or equal to 60. So then the person had to repeat. Make sense? Comfortable to everybody?
Yes, sir.
All right.
Let me just try it, sir.
You're ready to try it now? Is that what you said?
Yes, yes.
Good, because guess what? Here is it now. Question number 2. Prompt a user to enter the price and quantity for an item you wish to purchase. No. Listen, if the quantity, no. Put that back. Let me bring this in. So what am I doing? Head not there, no. Head gone for a holiday. All right. So it'll pay. So if the quantity is more, quantity is 3 or more, then output you'll get a discount. If not, you will get no discount. Clear enough to everybody?
Yes, sir.
Prompt a user to enter the price and quantity for an item used to purchase. Then display the total amount he or she'd have to pay. If the quantity is 3 or more, then output, you get a discount. And I put that in quotes because I want to put the phrase on the screen, you get a discount. Like I always say, you move to the next grade or you're going to repeat the grade. Just put the phrase there, not to calculate anything. And if not, you will get no discount. Could you guys tackle that for me, please? And it will be good, just advisable, just saying here, if you can save each question as a different name, so you can go back in Raptor and see what you have been doing. So you can see how your growth going through from face to face. You can refer to your assignments each time to help you when you're revising this stuff later on. All right, we're good with this, guys. Everybody good? Let me share this link again. So everybody can go and see the assignment. Copy the link. Share it in the chat. So you can go on it and see the the classwork. So guys, can I walk out from a computer for about 10-15 minutes and you guys work on this by yourself? Because I really want you to solve this on your own.
Yes, sir. Yes.
Yes. Go there.
Okay. All right, guys. Awesome. So I'm going to walk away for a few minutes, but I'll come back about 15 minutes time and see where you are. All right, cool. Put this thing on pause. The recording.
Thank you. That's true. All right, so see my screen?
Yeah, we're seeing your screen. So I'm gonna explain to us now what you're doing. Yeah.
Okay, explain.
Yeah.
Let me preface this by saying I'm not a teacher of information technology.
No problem. You might be in the right gang.
All right, so
yeah.
So we need to get the counter started. So I did that the first thing.
Yeah.
Then within the loop, I want to get their name, their age, do the calculations.
Right.
Then I want the counter to stop when it gets to 5. But as you said, the example before, you have to keep adding incrementally.
Right.
Which is why this.
Right.
And it works.
All right. Awesome. All right. You go non-IT teacher, we're bad for IT.
But you're not seeing, okay, you're not seeing.
No, sometimes you don't show. You have to drag that window onto the screen so we can see it.
It is.
It's there?
Right there ready for me.
Well, sometimes that happens. Execution console. Did you say share whole screen or just share the Raptor? Did you say share screen?
Share the Raptor.
Yeah, that's why we're not seeing it. Because if you share the screen, we see everything that you do on the screen.
Hold on.
Yeah.
Hold on. So let me try to share again. So share screen.
Yeah, share whole screen,
Entire
not
screen.
just a window. Entire screen, yes.
All right. Share.
All right, now we're seeing it, yeah.
So let me start over because I got an error with that one. So it's all this one. One is 15. This is 2.
Oh.
2 is 16.
Yeah. You have children?
No.
Three.
I hope your husband agree with the names when you start having them 1, 2, 3.
No,
At
the
least you know
reason
who
I
I
did it
come
this
first.
way is because you can't say that it's 5.
Yeah,
So now
I know, man. I get you.
you know,
But
I lose my remember where I reach.
you're at 3. You're at 3. Eh?
You can't mix number and strings, you know. I
Yeah,
did
yeah.
so.
Yeah, man. We saw what you're doing, man. We see what you're doing.
Yeah, but it does. Okay, so if you look over on the side here, it does
Yeah,
work.
yeah.
So it says you are. So it does work.
Yeah, man. I get you, man. I see it works. Yeah, you need to get some names like what I have, like Runkusa, Malvine, and Gladys. Yes, them
That's how you
name
keep
they run the place. Ludlow and Winky Eye. Yeah, man. Some good names like those. Anytime anybody decides to have any children, just tell Bantan and make Bantan name them for you.
Okay. I
All
don't
right.
think so.
All right, guys, come. Who next? Who next? All right, so Carrie Ann went a while ago. Hers works
All
fine.
right, let me call
Boy,
out because I
let me
might
try
do
you
have
about
to
the
log
Hold
off.
on, allow Mr. Lily. Where the ladies go first? Where the
all
ladies
right,
go
but
them go first? Yeah.
I don't know if I can match up to what Miss Freed just did now.
All right, Carla. I might have to jump off soon, so I'm sharing now.
All right, no problem, man. Go ahead.
All right, so initialize the count, and then I start the loop.
Right.
And I say count equal count plus 1.
Right.
Then please enter your age. Do the if statement here.
Okay,
so if
cool.
the age, if it's a yes, then it will be 21 minus age.
Right.
If it's a no, you're already 21.
Okay.
And then here now, the statement, you'll be 21 in whatever years. And then the count, if it the loop,
Yeah.
if count equal 5, if yes, it ends. If no, it continues going around.
Okay. Wow. That's you. Why, Miss Carla? You're really IT teacher, man. You teach IT, not you?
Yeah.
You're making contingency for the fact that if they even include the age over 21, you know, or something. Yeah. Good. Put it to the test and so let me see, you know, before you run away, you know.
So I put 12 in first.
Yes. All right, cool.
I put 21, so I go to the no side.
Right. Okay, cool. Awesome.
And there it is.
All right.
You'll be 21 in 9 years. You're already 21.
Okay. And guys, I want you to notice something because we have always seen it there, but we never really highlight it. On the left side, we have age, and then you have age 20, count equal 5. That's mucking up almost like a trace table situation where it's actually giving you the value as it's running in that loop. So you can pay attention to the left side right below the last symbol, the window there, where it's age, and it's actually populating it like what it would do a trace table. So those are things you can look at as well, because for those of us who teach IT, we know a trace table, it's a manual process you go through to make sure your program doesn't have any logic errors. Logic meaning it is giving the right output, you're doing the right calculations. So it's something to pay attention to and to observe while your flow chart is executing. All right. Next up.
Okay, remember to send the recording.
Yes, man, I'm recording this one. Yeah, when I send it, man, definitely.
Okay.
All right. Anybody else? Who's up next?
I can go ahead.
All right, no problem, Mr. Michael.
So it's share the entire screen, right?
Yeah, share entire screen, yeah.
Everybody's seeing.
Yeah, it's coming up. Michael, I started sharing screen, but the internet may be behaving a little bit laggy. Sunday evening, everybody online all over the world.
I'm not sure.
Messaging family.
All right, so
All right, share again because I'm still not seeing. I see Michael is has shared started sharing his screen, but I don't see the actual objects and so on. Actually, the actual screen.
Oh,
it could be the internet because if the internet's getting sluggish, I swear we see it now. We see it now. Yeah. Now, guys, pay attention to the left. On the left side, right below the flowchart symbols, you'll see it's running. Yeah.
I can just share this, the main screen.
Yeah, we see something happening there. Some glitches going on there. Some glitches definitely going on there. All right. Can someone else share other than Michael? Because Michael having some serious internet problems. Or it could be us, any one of us along the line too. Denzel.
Yeah, yes, sir, Bantam. I'm not finished as yet. I've been a challenge.
Okay.
With my loop, I'm going to share my screen.
No problem. No problem. Go ahead. All right. You select share entire screen. Years left to reach 218. Whoa. Some serious people have some man.
The loop.
Yeah, we're not seeing your entire. Select the option that says entire screen.
Entire screen.
Also, yeah, entire screen also because we're just seeing the console, the execution console for the flow chart. That's all we're seeing.
All right, they're going to.
Yeah. Okay. All right, go ahead. Right now, let's know.
Yeah, I have some challenge with the loop.
Okay,
here.
loop.
Right, to come down. This is supposed to come down, the bottom down here.
What you do? You see the part where say enter age, get age?
Yes.
Hold on to that shape and pull it up right into the loop, right below the part that says loop, right below that symbol. Pull it up.
Right.
No man,
Right.
just pull it up.
Pull it up.
Yeah, just put like drag and drop. Yeah.
So?
No man, right below the loop, right below this. Like, yeah, that's fine. You can just drag and drop them like that. The counter as well. Yeah. Just drag and drop all of them inside the area. You can put them above the, preferably put them above the counter. Or you can believe it yourself if you wish to, but preferably put them above the counter. So All right, cool. All right. Reduce the zoom it down to about 125. The program ends, right?
Yes.
Yeah, because
It's not going to loop.
right, because counter is less than 4. Counter starts off at less than 4, so it would stop right away. Because I say counter less than 4, yes, it goes straight to the end. So change the less than sign to a greater than sign. Edit, change to a greater than sign. Done. And no, greater than great as a less than sign still.
Greater,
yeah, yeah, done. And then now let us see.
Calculation pattern.
Yes. So you got all the results you wanted, right?
Huh?
You got the results you wanted, right?
No, the calculation part, no calculate properly. At age?
Yeah.
21 minus age.
21 minus age. And years left is 21 T age. That I think it's look like it worked properly to me. I'm looking at the flow chart over the left-hand side, and that's what I'm seeing. It looked like it worked properly to me. Because T age would have shown the amount of years left, right? The last
yes, that's true. Yeah, true. And left hand side, yeah. All right, thank you.
Yeah, man.
Mr. Banton, are you hearing me?
Yes, I'm hearing you, yes.
Yeah, I think there was a spike in my internet a while ago.
Okay,
So,
no problem.
I can try to share it back and see if it goes through.
Okay, no problem, man. Go ahead.
All right, so are you seeing my screen?
It's coming up. Let's just see. It says Michael Gidar Singh has, yes, started sharing screen. Yeah. All right, cool.
All right, so let me run it. All right, so I'm gonna enter 10, 20, 21, 12, 13.
Yeah.
All right, so I'm gonna enlarge this.
Yeah, man.
But that doesn't help. Yeah.
So what you're saying, you say you have a problem with it?
No, I'm not saying I have a problem with it.
Oh,
I was
okay,
just
okay.
showing
Yeah,
you
man.
the solution
It
I have.
look like it worked fine to me. Yeah, man.
Yeah.
Works fine, works well. What I like though is that many of our colleagues, I guess, many of us are computer teachers are inclined leaning in that direction. So we made contingencies. So if the person entered more than 21, it automatically consider that as well. That's a good thing to do. That's a good way to look at it. So this program, yeah, good. Everything else so far is basically perfect. So anybody else with anything else to demonstrate? Because we're running until late now, and I don't see Kevin. Mr. Granted about?
Yeah, man, we never leave, man.
Never leave. Yeah. So if nobody has anything else to show, Mr. Grant is going to show us now how the conversion from decimal to binary works. All right, and this will involve everything we learned so far. Modulus division, selection statements, of course, will be in that mix automatically, and loops, and so on. So all the skill sets will be used, not to mention the concept of floor as well. And I guess once you have floor, ceiling will also automatically be implicit in that as well. So we're going to go to the last one now, maybe about 30 minutes of class, because it's a marathon class now from 4 o'clock running up to 8 o'clock. So Mr. Grant, keyboard, mouse, microphone, screen, everything is yours.
Bless you. We probably won't need to take too long. The longest part will be figuring out how it works.
Yes.
But if everybody is cool with how how to use the symbols in the flow chart and stuff like that, then once you figure out how the conversion works, then everything else is just a matter of putting that in the flow chart. Let me give a disclaimer. I think Mr. Banton's approach was a lot simpler than mine to solve this problem. So let me put that out there from now. But the idea is, if we are going to convert any number, we're going to start with the number 5. All right, convert a number to binary. You see my screen, right?
Yes.
Yes.
All right. So just like all the other problems, you first need to understand what is required of you. What is required of you is to take a number, for example, 5, and express it as binary. Now, how you do that depends.
Kevin, you can use a bigger number so we can get the feel of a flow or a feel of it, like say 13, 15, 17, 21, a bigger number, so we have quite a few to go through. So we get stage 1, stage 2. Yeah, man. Thanks much. Try 17 now, or 18, or something like that.
Maybe 17.
Yeah.
I'm not gonna use 25, but I'll try to remember if that one they did take really, really long. All right. But from what I can understand, there are 2 ways people do it. Well, maybe 3. Yeah, 3 ways. There's a subtraction method. There is the place value method, which is my personal go-to method. And then there's the division method. So how you write the flow chart depends on the method you use. I'm going to start with the place value method because I already have that one set up. So I already know in my mind how it works. So I'm going to use that just to explain the process first. And then if you want, we can try a different process and we work through it together. So you get a feel of how do we take the approach and turn it into a flow chart. But quickly though, the subtraction method is simply you take away 2 multiple times. And you keep subtracting 2. Let me go from the mouse. You keep subtracting 2 until you can't subtract 2 anymore. And then basically the binary version, how many times you subtracted 2, and yeah, that's basically what it works out to be. It's very similar to the division because in a simple sense, division is just repeated subtraction. And so if the division approach works, the subtraction approach will work. It just looks a little bit different. I start to find the mouse here. It's kind of weird for right on this touchpad. All right, but I think most persons are familiar with the division approach and maybe the place value approach. So I'm going to start with the place value approach first, though. Because as I said, I already did that one. So I already know in my mind how it works. I'll use that as a demonstration. And then because it's probably the most technical, if it makes perfect sense to you, then every other approach is supposed to simple to you. So the place value approach, what we're doing at this point is understanding the task, understanding the problem. I'm pretty sure Mr. Banshan mentioned it, that writing your flow chart is literally how you solve the problem in a flow chart approach. So if you don't properly understand what you're doing, that is when the flow chart feels like utter foolishness to you. The task given to us is a concept that perhaps while we were doing math, our teachers probably never really explained it properly to us. It's as simple as tens and ones. When they give us something like 12 plus 19, and them tell you 2 plus 9 is 11, 1 carry the 1, and they perhaps never properly explained why is it we carry 1 and we keep 1. The reason for that is that just like binary, the decimal system, what we call tens and ones, are limited to certain values. In binary, what are the values we're limited to?
0 and 1.
0 and 1. In decimal, you're limited to the digits 0 to 9. The moment you pass 9, that no longer fits in that place value because you can only hold digits 0 to 9. And so what literally happens here is you got 11. But because you're in the decimal system, place value system, tens and ones, you must convert 11 to decimal. In layman terms, you can get 10 out of 11 one times and it leaves a remainder of 1. So that one time that you got 10 out of 11, that is the 10 that you carried. And your remainder of 1 is what you left. And then you said, no, all right, I have 1 and 2. 1 and 1 gives me 2. 2 is a digit that fits between 0 and 9, so I can leave the 2. So all along, you've been doing the exact same thing that you're doing with converting to binary. You just probably never know. And you keep doing that over and over and over and over and over. The last, anybody?
Go again. Go again.
All right. So the decimal system only fits the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No 10 no in there. These are the digits that that system fit.
In other words, every number in decimal system is represented using 0 to 9.
Right.
Those digits, every number is represented using 0 to 9. Those 10 digits represent every number.
So like the number 12, it's a single number with 2 digits. Those digits being 1 and 2. The number 9 is a single number with 1 digit. That digit being 9. The number 1470 is one number with 4 digits. 1, 4, 7, 0. So every single counting number that we use uses digits, one of these digits. Every single one of them. And that's what our tens and one was. You remember tens and ones? 100 tens and ones, that's what it is. Hundreds, tens and ones is simply representing a base 10 number using place values. Ones is literally 10 raised to the 0 power, which is equal to 1. That's why we call it ones. Tens is 10 raised to the first power, which is equal to 10. That's why we call it tens. So you get 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Once you reach 100 now, 100 don't fit in tens. 100 is literally 10 raised to the second power, which is equal to 100. 100, 200, 300, 400, 500, 600, 700, whatever number you can think of, will use one or more of these digits. So when we were doing tens and ones now, and them teach us to add 12 and 9, 12 literally means there are two ones, literally 1, 2. And there is one whole of 10. Because when you add one whole of 10 plus two single ones, you end up with the value 12. And then say you add 9 to that. 9 ones, because it don't reach 10 yet. Why they tell you now when you add this to put on 1 and carry 1 is because 2 plus 9 is 11. 11 is not a digit that fits between 0 and 9. Which means the number 11 has a group of 10 or more than one group of 10 and some single ones in it. How do we figure out how many 10s can be found in 11? You can subtract it or you can divide it. You take 11 and you subtract one group of 10 from it, you get one remainder. How many times did you subtract 10 from it? One time, and that's why them say you carry 1. Let's take a number like, no, all of them are going to work out to be that way, right? But that's why them say you put on 1, you carry 1, which is one group of 10 out of 11, and you have a remainder left of 1. This is why now when Mr. Vankatesh was talking to us about converting, I'm going to use a smaller number, 5. No, 3. 3 is even smaller. And he says you're converting the number 3 to binary. He says 2 into 3, I not even remember when you write it. 2 into 3 goes what? 1 time and remainder 1. How him did you write it again? You write 1 here.
You put 1 underneath the 3 and, well, I don't remember how him do it. Yeah, something like
this, right? 1 down there, so and remainder 1, and you start right from the bottom up.
Yes, you put,
yeah.
So it's like a 3-column thing. 1 with the number, 1 with the base value, and then 1 with the remainder.
Right, so it's a similar concept. If you do that with the 10 and the 11, you're dividing 11 by 10. 10 into 11, must say 1 time, remainder 1. The same thing here, so see there, you carry over 1, and you keep 1 down there, so. What you've literally done is converted the number 11 to base 10, or there, representing it there. You converted that number 11 to base 10. That's basically what you've been doing all along. The last nobody?
No, sir.
All right. So then, if that makes sense, then converting to base 2 is very much similar. If you think of the place values, instead of having hundreds, tens, ones, or thousands, this time around, you have them in terms of twos. You have ones, then twos, then fours, then eights, and then 16, and so on and so on. It's much like your tens and ones. You had ones, 10 times 1 is 10, 10 times 10 is hundreds, 10 times 100 is thousands, and then you have 10,000, 100,000, 1 million, 10 million, and so on, so on, so on. Seeing the connection? Talk to me, you know, if this don't make no sense, then anything we do in a Raptor not gonna make no sense.
Yeah, man. What's the connection?
Go again. Let me go again. So with normal tens and ones, we have it ones, tens, hundreds, thousands, etc. Maybe we never realize it, but if you check it out, ones is literally the number 1. Tens is literally 1 times 10. Hundreds is literally 10 times 10, which give you 100. Thousands is literally 100 times 10, which give you 1,000. 10,000s is 10 times 1,000, which give you 10,000. In other words, each new place value you make to the left, you're timesing the previous one by 10, because the numbers are written in base 10. That make more sense now, Michael? Michael still with us? Or the rapture start? Okay.
Michael, he have internet problems. He just drop out a while ago.
Okay, if anything, him with us. Stop me again.
Watch the recording or something. I will come back here. Yeah.
You know, this kind of reminds me of when teaching on between units.
Yeah, chip in and chip out, Sir Lily. So you know to catch everything I say. It reminds you of what?
Oh yeah, man. I was saying this kind of teaching
I lose you, Sir Lily. Maybe you want to type it in the chat because it'll break up bad. But I heard you say it remind you of teaching convert, but that's all I could hear. I didn't hear after convert. All right. So if the tens and ones make sense, this don't just work for binary. Every single number system. Base 2, you start at 1. So the next place value is 2 times 1, converting between units. It's pretty similar to that. Pretty similar. All of them connected somehow, some way, but we probably just never get exposed to it that way, and that's why we see them as different. But in the binary system, because the binary system is base 2, then when you start at 1, the next place value is 1 times 2, which gives you 2. And that means the next place value is 2 times 2, which is 4. That means the next place value is 2 times 4, which is 8. And you keep going. The next place value is 2 times 8, which is 16. And you keep going on and on and on. So when you get a number like 17 now, you are literally saying to yourself, well, which one of these place values can I fit 17 in? already you can see that you can get sick. Well, the next place value after 16 would be 2 times 16, 32. So already you see say, well, 32 can't work. 32 can't work. But you can get a whole of 16 out of 17 one time. And when you do that, it leaves you with a remainder of 1. So the next place value is 8. Can I get 8 out of that 1? No. So it's 0. Still remainder 1. Can I get 4 out of the 1? No. 0. Still a remainder of 1. Can I get 2 out of that 1? No. 0. Still remainder of 1. But can I get 1 out of that 1? Yes. 1 time. Remainder of 0. Because your remainder of 0 is you're done. So 17 converted to base 2 is 1, 0, 0, 0, 1. All you've done is to take each of these values and represent how many of them you have. You have 6, you have 1 16s, you have no 8s, you have no 4s, you have no 2s, and you have 1 1. Just like 10s and 1s. 17, you have 1 10s and 7 1s. That makes sense to anybody? Or me lose somebody?
Yes, sir. Yes, ma'am.
Very okay. Clear, sir. Very clear.
All right. So our task now then is to take this process and put it into a flow chart. It feels a little bit harder than the other examples that we've been working with Sir and Mr. Banton, because this one is not as spelled out and straightforward as the others. With the others, they tell you, you need to get a number and you need to do this to the number. This time around, our task is to find a way to translate what we've done into steps. And when we've translated it into steps, those are the steps that we put into the flow chart. Basically, what we've done so far, we have to analyze the step, you know. All of these place values are values of 2 raised to some power, every one of them. 1s is 2 raised to the 0 power. 2s is 2 raised to the 1st power. 4 is 2 raised to the 2nd power. 8 is 2 to the 3rd. So that means that 16 is what?
2 to the 4th power.
2 to the 4th, and the cycle keeps going on and on. Watch this now, you know. This is true for every single number system, every single number base. If you take 10s and 1s, 1s is 10 raised to the 0 power. 10s is 10 raised to the 1st power. 100s is 10 raised to the 2nd power. Thousands is 10 raised to the 3rd power. This is something that will work with every single place value. What that literally means, without even going to do it yet, if you figure out the flow chart to convert to binary, the same flow chart you made can convert to any number system except maybe hexadecimal, which Mr. Banton teach me earlier. If you figure this out, you can say to Mr. Vankatesh, said, yeah, limit me to base 2, man. Just tell me if it convert to any decimal, any value, any number base, because this system works for every single one of them. Me lose anybody so far?
No, sir.
All right. So how I think when I did this now, I think that I already know, without even going to the flow chart yet, I already know that this piece of information is critical for my program. Without this piece up here, so without telling the computer this to figure this out somehow, me can't accomplish my task. And that's where I start. So let me open up Raptor and share my entire screen instead. Oh, no, that's not gonna work. That ain't going to work at all. All right, print screen. I forgot if I share entire screen, the whiteboard not gonna show. Thank God for Microsoft Whiteboard. Hold on, give me a second, everybody. Print screen. So where did my snapshot go? There you go. Can I just copy you and paste you in a Microsoft Whiteboard? Yes. All right, come now and lose a board there. Close you and share entire screen instead. Hide. Oh, me hide a zoom 6 and 9 and all hide floating. The 9, you see. Yeah, the things I just see that little sick they just in front of you. All right. I make you bigger. Too big. All right, we can see, right?
Yes, we are seeing them.
Yes, ma'am, we're seeing clearly.
So I already know that this piece of information here, that part at the top that we ticked off, is critical for my program. You don't have to do it this way. Mr. Venkatesh suggested that you get a notepad and you write out your steps so you know your steps. You can do it that way. But because everybody there are so long, I'm going to just go and put into the flowchart as we go along. That all right with you?
That's fine, yes.
Yes,
All
sir.
right. So I need my program to figure out a way to do this. Raise 2 to some power, right? Which means that I need to tell it to do something. I need to assign it to do something. Because I'm going to base 2, I can do one of 2 things. I can just use the number 2 since it's just binary. I'm going to do over and over and over. In fact, I think that's what I'm going to do. So I already know that I'm going to write the number 2 and I'm going to use the number 2 over and over and over. What I need to figure out now is the place value or the power of 2 that I'm going to use. Because so far, I guess we guess it. No, we see the number 17 and we just go on work until we figure it out. So what we need to do is find a way to assign the exponent. We need to find a way to assign the exponent. And we can do the exponent one of 2 ways. Well, not one of 2 ways. However way you want to figure it out. But one thing is clear though. The exponent so far, we're using number 17. We're processing it as we go along, right? The exponent so far cannot be equal to or larger than the number we're given. For example, the number 17. Notice the number 17, the exponent we use turned out to be 4. If we use an exponent of 17, it would have been too big. We don't know just yet how we figure out to use 4, but we know so far that it can't be 17. It can't reach so far. It must be some number smaller than 17. Right? I'm going to use my initial process of working it out since I'm going through this with you all along. So I assumed, well, half of 17 is what? Half of 17 is what? 8? 8 remainder 1, right? And that seems close enough. Because I'm using base 2, I say, all right, let me divide the number I'm working with by 2. Already may have a problem, don't it? Number divided by 2. Already may have 2 problems. Anybody see problems so far?
What is the number?
You only need to see the remainder.
That is one problem. Well, not the remainder. Not the remainder, but that is one problem. This is going to give me a remainder. This is going to give me a decimal number, and I don't want a decimal. And who was it that said it earlier? What is the number?
Yeah, what is the number? Yeah.
So already my system will make a mistake, don't it? Before I can even tell this program how to calculate the exponent, I need this variable number. So I'm not ready to start here. I need the user. I need the user to give me the number first of all. And that's why they said, Mr. Banton and Mr. Vankatesh kept suggesting to us, just work the problem. Understand the problem. As you go along, it will become clear to you what you need. So we started somewhere and realized, no, we're not ready for this yet. We need the number. Enter the number to convert. I need that first of all. And now we call it number. So that's our input. Now we can go back to exponent. Our exponent, we're guessing. We don't know if it will work perfectly yet. We are guessing it is going to be the number divided by 2. But somebody mentioned this is going to give me a decimal. And my exponent cannot be a decimal. No. They are all whole numbers. 0, 1, 2, 3, 4. So how we solve this?
You don't have my number. Tell her if you call Jasmine.
Hold on there. I who no mute. My make people in your business. Wait there. Everybody hearing me?
Yes, sir.
Yes, we are.
Yes.
Well, I know you alone. We are here still, but we are here.
Yeah, me did I try find if we could have mute him, but you may hide the thing. Me can't see this room right now. But somebody mentioned a problem. This can give out. Notice me say can, because if this was an even number, this would work perfectly fine. But it so happens we're testing with an odd number, so we see the problem readily. This is going to give me a decimal, but I don't want the decimal. What I want instead? The whole number part. So how me fix that now? All right, nobody not sure yet. So this is where Sir introduced us to Floor. And just like Mr. Banton, I never even know what Floor was until Sir mentioned it. But if you reach a stage like this and you don't know how to solve a problem like that, my suggestion is go to the help, general help, math in Raptor, and look on the formula demo there. Know what I'm looking for there, so don't do anything more. These are, see one here, ceiling, which is the opposite of floor. This is if it rounds up the number and it will give you that. Floor now rounds down the number and gives you that. Make sense?
Clear.
All right. And how you use floor, it is floor, and you put in quotation the division that you're working out, or whatever you're working out. So I want the floor value of the number entered divided by 2. This is not the exponent we're going to use, however, because as you can see, 17 divided by 2, the floor of that will give me 8. But that's not the exponent I need to use, which means now I need to tell the computer something else to get to the actual exponent that I want. I know I want the exponent to be 4. What can I do to get it to be 4? Anybody want to suggest, or I must just go along with how I thought about the solution?
Go again.
I should just go ahead with how I come up with.
Repeat your question, because I'm here.
Oh, the question, right.
Yes.
So as it is now, if I run this and put 17, my number is 17. My exponent is 8. We didn't tell it to print anything. But if you look to the left over here, it tells me that my exponent is 8. But to convert 17 to binary, my exponent can't be 8. I know my exponent must be 4, because that's what our test showed. So this step got us close, but didn't get us to where we need to be.
So divide the exponent by 2?
Well, we could do that, yes. We could divide the exponent by 2. Here's another problem now. If we just go ahead and just put in another assignment here, right? Would continuing to divide over and over by 2 work for everything? Let's say the number was 18. Let's divide the exponent by 2 again. Let's call this exponent number 2. And we say with the floor value of the exponent divided by 2 again. What if the number is 18? No, I don't want to use 18. Let's use a number I know not gonna work. 32. Right, 32. So with 32, the exponent must be 5. If I enter 32, it's going to tell me yet again that my exponent I should use is 8. Is that correct? No, for 32 to work, see it here, my exponent needs to be 5. So this never work. So just assigning it randomly, me just deciding, say, yeah, man, I'm gonna keep dividing by 2, will work for 17, but not every number. So any ideas then, what else we might have to explore? Or you want a hint? Let me rephrase the problem.
Can I miss out something? What is the floor again?
Or the floor just gives the whole number, the lowest whole number. So if the answer is 8.2, it's going to give 8. If it's 9.8, it's going to give 9.
All right, thanks.
So our problem here, is that we keep assigning. We do the calculation ourselves, and then we keep assigning and telling it use this instead. But that will work if we're using a specific number, if we're converting a specific number. We need the program to figure this out on itself. So any clue then, what kind of symbol we have to use instead?
The mod.
Let me say again, symbol. Never say operation, symbol. So far, we keep assigning, we keep telling it that you must divide by 2.
Selection.
Come again?
A selection.
Something like that, precisely. Because if we keep working out the math for it and telling it exactly what to divide by, we're going to end up with a problem with other numbers. But if we can use some sort of logical process that it can use to figure it out on its own, then it will work with any number we enter. So this is not what we want. Instead, I'm going to go ahead and use a loop. And this is why I'm going to use a loop. If me sit down and try to tell it exactly what to do over and over and over, it better me just take one piece of paper and calculate it myself. Make sense? But if I use this and get close, I can figure out a logical sentence that if it meets this criteria, it has figured out the exponent by itself. I got it close. All I need to do now is keep subtracting until I get to a stage that I need. In other words, I know which exponent to use when this number, when I found the highest number that I can take out of this one. 2 raised to some power gives me the highest number that I can take out of 17. That is when I know that I found the exponent I need. So what if I take 2, right now with the 2 to the 8th power? Would 2 to the 8th power be bigger than 17? Enough bigger. So I can't use that. 2 to the 7th power, bigger than 17, enough time. 2 to the 6th power, 2 to the 5th power, all of them bigger than 17. And every one of them were bigger than 17, can't work. So I can tell the program then, well, take away 1 from the exponent I have so far until 2 raised to that exponent becomes either me get it to 17 or less, some little bit under 17. Make sense? Or me need to say that again?
Yes.
All right, it makes sense. So I just need it. I got somewhere. I just need the program to keep going down with the exponent until I get a number that is 17 or less. Instead of me telling the computer, divide, divide, divide. It will eventually figure it out itself. So when should the loop stop? When 2 raised to, where it go? That symbol raised to the power of my exponent, whenever it is less than or equal to the number I entered, stop. That is the exponent I need. We understand the condition? I spell exponent wrong though. Should be capital E.
Go again with that one expression there, please.
All right. We know that 2 to the 4th power is what we need to convert 17. And we know that because 2 to the 4th power is 16. 16 is less than 17. Any number, any place value that works out to be bigger than 17 can't work. So that means we need a place value that is less than the 17, which is the number that was given to us. So far, we found a way to narrow down the exponent. We got to narrow it down to 8. But 8 can't work because 2 raised to the 8th power is bigger than 17. 2 raised to the 8th power is 256. That number is too big. So we got one number less. All right. What about 2 raised to the 7th power? Still too big. What about 2 to the 6th power? Still too big. All of them numbers are bigger than 17. 2 to the 5th power. Still too big. 2 to the 6th power. Sorry, 2 when we reach 4th. 2 to the 4th power. Perfect. So in other words, I can tell the program to continue looping until 2 raised to the exponent is less than the given number 17, given number 20, given number 15, whatever the number is. When you take 2 and raise it to the exponent, it must be equal to or less than that number. So that is when my loop should stop. Little bit clearer?
Yes, sir. Yeah, man, much for me.
It feels technical because, as I said before, the difference between the task he gave us and the others is that we have to be the ones to figure out how the process actually works, how the conversion actually works. And that's why it feels tedious. That's why I feel like you can't do it. But just take it one step at a time. So now we figure out a perfect way to calculate the exponent. However, it can only work if we continue to subtract 1 from the exponent, keep going down. That part we don't have yet. Me lose you?
No, something like that.
I mean, are we at top, my boss?
Oh.
So we know when the loop must stop, but so far we don't tell it what to do yet if it not reach the condition. What does it need to do? It needs to, I'm just gonna copy this and paste it here. It needs to subtract 1 from the exponent. And it must keep subtracting 1 from the exponent till when we raise 2 to it, it is less than or equal to 17. That makes sense? Or explain it again before we run.
When you explain, you were saying something about the floor earlier. I figured more or less now. I was just thinking about it that you had to subtract 1. But like I wasn't really thinking about it that much because I was on the phone talking to somebody. So now that you're going through it, I'm like, oh, yeah, man, I get it.
All right, so we can test it to see if we get with 4 now, because we know the exponent must be 4. So we can test it now. All right, so
go ahead, man. Go ahead. Yeah.
Yes, go ahead.
So the number should be 17. So far the exponent is 8. Change it to 7. Change it to 6. Change it to 5. Change it to 4. Perfect. We figured out how to get with exponent now. So we done the hurdle. Because see, tell you now, the exponent to use is 4. So now we figured out which place value to use. Which takes us to the next step now. Now that we know which place value to use, we can begin the conversion. And what usually happens with the conversion is 2 to the 4th power is 16. We take it away from the number that was given. Right? Or you can think of it in terms of division. Division might be easier to think about, to write the code. We divide the 17 by 16 and get 1. That's why we write 1 this. So So now that we figured out our exponent and we come out of the loop, we can now tell it what to do. We can now tell it that our number 2, we're going to create a new number now, sorry. Let's call it number 2. Our number 2 is, no, I'm not, can't use number 2, we have to use number. Have to use number. The reason why is each time we change the number, we need that new number to use. Otherwise, we have to go find another way if you put in, if you put in a new assignment over and over. So I'm just going to leave it at 1 so that it keeps changing the number over and over. That makes sense? So to convert my number, I need to divide my number by 2 raised to my exponent. But this can be a problem. What is the problem now? Same problem as before with division. Anybody? No? What is 17 divided by 16?
1 remainder 1.
1 remainder 1. That is our problem. We don't want no decimal as the answer. So we have to use the floor. No, wrong thing I use. No, not necessarily. We can do it this way if we want. Yeah, I'm wrong. We actually want the remainder. We want it to print the answer, but we want to use the remainder to continue dividing again. With me? So yeah, I'm wrong. We want it to print the answer or the floor, but we need the remainder to keep going again, to keep dividing again. Me mix up nobody? And we need to go again? All right, let me go again. Let me assume I mixing up. So let me go again. When I divide the 16 into the 17, I get my 16 into 17, I get my 1 remainder of 1. Then I need to go ahead and divide again. 8 into 1, 0 times. 4 into 1, 0 times. 2 into 1, 0 times. 1 into 1, 1 time. So I need this remainder, because I need to divide it again. Did that clear it up?
Yes, sir.
All right. So that was a mistake I made. So it's not the number needs to be changed to the remainder, sorry, or modulus. Which one did I use? Which one am I more comfortable using?
Remainder for me.
Remainder. All right, so it should, the number should change to the original number and the remainder of dividing it by, what is it? 2 raised to the exponent. Did I write this properly? Yes, I did. Thank God. So we're dividing, in layman terms, 17 divided by 16 but I only want the remainder. So the remainder is what is going to become my new number. But I actually want it to print the floor value of that, because this is actually the number that I'm going to write down. I want it to print the floor value of the number divided by 2 raised to the exponent.
So she's supposed to write, she's supposed to see, she's supposed to write what was done.
So let us test and see if we are going to get 1. 17 is going to calculate my exponent. Exponent is 4, so it leaves the loop. It prints, what does it print? It prints 0. What did I put in? So something not right. Oh, this need to come before this, because it changed number. See, same problem you did tell me about Mr. Banton. When you change it, you change the variable, the value of the variable. So it need to print before it change the value. Run it now. 17. So it should print 1. There we go, it prints 1. So we know we're doing good so far. Me lose anybody? No lose nobody. All right, so we're doing good so far. We get the first digit. Now, how did we get all of these other digits? By repeating the process. So if we're repeating the process, what do we actually need in our flow chart?
An next loop?
A next loop. As simple as that. Notice the approach me I take, you know. I'm going along. Just start small. Yes, you know what the answer should be, but no kill off yourself. If you're kind of slow at it, no kill off yourself. Start small. Make little accomplishments. You realize, say, yeah, man, me figure out the first digit. Then you tell yourself, now, what process did I go through to get the others? I literally repeated the exact same process, which means I don't need these to be standing alone. I need these things in a loop. So I actually need them in a loop. When does the loop stop? In other words, when do I stop dividing? When do I stop dividing by 2 to an exponent? Just take a look at the chart we have here, someone. When do we stop? We are 2 to the 4th power, so we divide. 2 to the 3rd power, we divide. 2 to the 2nd power, we divide. 2 to the 1st power, we divide. 2 to the 0 power, we stop. When do we stop?
When 2 raised to 0.
Precisely, when 2 gets raised to the 0 power. So it looks like our loop will end when our exponent is going to drop below 0. The moment the exponent drop below 0, you don't want it. We don't calculate that. That's when the loop ends. All of that we got just by looking at how we solve the problem by ourselves. The moment the exponent drop below 0, we don't want it. The last exponent we must have is 0, which means that what is going to happen to our exponent in the loop? In our loop, what should happen to the exponent? We start at 4. How we going to get to 3? Talk to me, you know. No talking means say foolishness, me a chat and nobody not understand what go on. Oh, somebody type it. Yeah, we subtract 1, which means that in our loop, we need our exponent to continue dropping. After we do the first set of stuff, so Kyle asleep. Oh. No, until you sit down. Sorry about that. I have a 1-year-old and my wife look for me like, so when my baby there. Let me say again. Right. So we know that after we do this, the exponent needs to drop. After we've done the first division, we need to subtract the exponent again. So the same assignment here, so I'm going to copy it and bring it down here, so and paste it. I need my exponent to drop again, and it needs to continue dropping until it falls below 0. So now that we have our loop, them something here where we did place, are they at the right spot? No, they are not at the right spot. Exactly. This shouldn't happen when it exits the loop. This should happen when it is in the loop. And this needs to happen before me alter my exponent. This can probably happen. No. This needs to happen before me alter the exponent as well. Because this is what it will print. I should not change my exponent until after I get my 1. This now is going to give me the remainder, the next number I need to divide. So that have to happen before me change my exponent again. And now that I've done every single step before I move on to the new exponent, I can now alter my exponent. So what should happen now is it will enter the loop, 17 divided by 16, print the 1, then it figure out the remainder, which is 1, and then cut my exponent by 1. Then now it will come round, 1 divided by 2 to the 3rd power, which is 8. It should print 0. And then it should change the 1. Well, number, the remainder that you get when you divide the number by the exponent. Yes, so this should give me 1 again. And then it will cut down my exponent over and over. At this point, you can actually take for granted that you've done everything correct so far, because you did it independent of the loop and you are satisfied. All you needed to do now is put it in the loop. So we can go ahead and run and see. This as it is now should give us the answer 1, 0, 0, 0, 1. Let us see. Number is 17. It's calculating the exponent. Exponent is 4, so it exit the loop, enter the new loop. All right. See, it's printing them. 1, 0, 0, 0. Give us a 1 now. 1. Leave the loop now. Perfect. You're done. And this should work with every single number we're converting to binary. So we can test it. I'm gonna test it with a small number. So let's test it with 5. I think 5 should be 1, 0, 1. Yeah, that look right. Yes, 101. So let's test it with a small number, 5. 5. Our exponent should be 2. Perfect. It uses 2. It prints 1. It prints 0. It prints 1 and stop. Working perfectly so far. Let's try it with a bigger number, like 25. I'm going to Google 25. Or if anybody Google it faster than me. Decimal to binary. What was it? 25. So we should get 11001. This is what we should get. 11001. So let's run it. I'm going to run it full screen now because we're done with our working out. So 25 should be 11. Remember, when we're done, we'll look. Where's console? Oh, so it's still calculating the exponent, which is good. Where's the console? Why it not stay up? All right, it's not staying up for some reason. All right, we got 11001. What did Brave say? 11001, working perfectly. And so we're done. In summary, all we did is to take it a step at a time. Let me bring up the whiteboard again. No, wrong something. Here we go. We took it a step at a time. We calculated it ourselves and we step back and we look. How does this process work? And for each thing we figured out, we put it in the flow chart and we test to see if that step works. It works, we move on to the next thing. So the first thing we did, we realized everything is 2 raised to some power. That's why everywhere we look, you see we have 2 raised to a power, 2 raised to a power, 2 raised to a power. We needed to figure out the exponent. We realized, say, well, the exponent cannot be bigger than the 17, the number that is given. So we need to find a way to cut it down drastically. And so we say, since we are used base 2, make we just divide it by 2 and work with that. And we realize, say, the exponent still too big. So we need to cut it down until we get a number that is smaller than 17. And that's what we entered here. Cut down our exponent. That's why we needed a loop, because we need to keep cutting it down until we get to an exponent that is equal to, when we raise 2 to the exponent, we get the 17 or less. That's what this loop did. And then we realize now, all right, now we need to convert. How we convert? We divide the original number by the 2 raised to the power. And that's what we did here over and over and over. Well, before we did the loop, we just did that. We did the number divided by 2 raised to the power, but we only want the whole number part. That's why we use floor. And then we realize, say, well, we are going to need the remainder. And so that's why we say, let us change now the number to remainder. As a matter of fact, at this stage, we don't even need to change the, no, we're not going to trouble it. We're not complicating it further. We'll just change the number to the remainder, and that's what this is. And then we realize now, all right, we need to repeat that process. So we actually need to put this into a loop. But when do we stop repeating the process? We realize anytime the exponent drop below 0, we stop. And so that's what we put as the process stops when the exponent drop below 0. Put everything what we did make before into that loop, And then now cut down the exponent again. Everything we've done is we just took it step by step and put it in as we went along.
Mr. Grant, go through the all right. So you said that for the first part at the top, right? As long as so right here we get the number from the user, right? We do the floor to get the exponent. Then you say
Or not necessarily to get the exponent, to get an exponent we can start with.
Yeah.
Because you don't have to do this, you know. You could have do this from the get-go and just keep subtracting 1. But if you do that, you sit down and you wait on the program for hours if you use like a number like 100. As a matter of fact, this right now, the way we have it right now, if you use a big number like 100, you sit down yourself for long. Because it's going to start with 50 and it's going to subtract 1 from 50 over and over and over.
Okay.
Right. I found a way to cut it shorter than that, but what is important right now is for you to figure out how do we come by something that we can work with. All right, continue now. Sorry about that. Yeah, so this step is just to give us a number we can work with.
Number now, right? And then once we get that number now, we said 2 to the power of that number. If it is less than or equal to the number that we got originally, we say that number minus 1, right? So in the case of the 17 we're using, it would take 1 from the 8 that we get, right?
Right.
Whole thing. I mean, it would continue until we get to 2 to the power of 4, which gives us a number that, you know, we can take out of the 17, right? And then we'll move from there to the next part where it says if the exponent is less than 0.
Yeah. So in other words, in layman terms, hold on, before you continue, in layman terms, this part is the actual converting to binary. That's what this part is. And so we realize, so we stop converting when we have 2 to the power of 0. Everything up here, so, is just to figure out which exponent we're starting with so that we can start converting. All right, sorry about that. Go ahead again.
Okay, so because I was